Consider the surface given by z equals x squared plus 2y squared minus 2x plus 4y. And at one point, let me emphasize this by making these parentheses instead of these V braces. The tangent plane to the surface is parallel to the xy plane. What is the z coordinate of that point? Equation of a tangent plane, when you're given z as a function of x, you're given z as a function of x, then we have the equation of the tangent plane would be z minus z naught is the partial derivative of f with respect to x at x naught y naught times the quantity x minus x naught plus the partial derivative of f with respect to y at x naught y naught times y minus y naught. The f here is the function x squared plus 2y squared minus 2x plus 4y. The x partial is 2x minus 2. The y partial is 4y plus 4. And if we wanted to evaluate these guys at x naught y naught, we'll just be plugging in generically x naught and y naught, and what we get out is 2x naught minus 2, where x naught is some number that we are to find, and 2y naught minus 4y naught plus 4. Now, the tangent plane, the normal vector to the tangent plane is going to be exactly the vector f sub x at x naught y naught, f sub y at x naught y naught, and negative 1. How do you get that? Well, equation of the normal to find a normal vector, you find the coefficients on x, y, and z, and so that's what this is what they would be. Now, this is the normal vector to the tangent plane. Now, we're in search of the point where the tangent plane is parallel to the xy plane. Now, the xy plane, the normal vector for this xy plane is anything that has 0 as a x coordinate or I component, 0 as a j component, and 1 or any constant in the k component. And so that's the normal vector. Any normal vector to the xy plane looks like that. If you're to have a normal vector, if you're going to have parallel planes, they have the normal vectors that are scalar multiples of each other. And so what that means to us then is that the normal vector to the xy plane is some scalar multiple times the normal vector to the tangent plane. What that's going to mean to us is, this here's a scalar, we have exactly 2x naught minus 2, 2y naught, 4y naught plus 4, and negative 1 as the normal vector to the tangent plane. How could this be some scalar multiple, or how could we take this and multiply by something to get the normal vector to the xy plane when the xy plane's I and j components are 0? These guys are 0. And so it must be then that these guys are 0. And so that's going to mean to us that 2x naught minus 2 is 0, or that x naught is 1, y naught plus 4 is 0, or that y naught is negative 1. That has to be true. We can't have x naught and y naught be something different, because I wouldn't be able to get this equation to be true. Since these planes are parallel planes have normal vectors that are scalar multiples of each other, and this is just some scalar this is some number, some scalar multiple, and so m is some real number, scalar, some real scalar, and so it must be true then that those two are 0, because it isn't true that the scalar is 0. And so here C is not 0. Okay, and so yeah, we have x naught and y naught. Now we just take these two together and go out and find what z naught is back into the surface equation. X naught squared would be 1 squared plus 2y squared minus 2x plus 4y to get what z naught is. 1 plus 2 minus 2 minus 4. And so z naught is negative 3. And that would be your answer to the question. Okay, great.